the day, number 15. So we're still talking about how to prove triangles are congruent, but we're going to take it one step further. So for example, the conclusion is no longer that just the triangles are congruent. We're going to go a little bit further and talk about, well, now that you know the triangles are congruent, what does that tell us? Okay. And another thing that's different now is that they're not telling us how many steps to use. So you can use as many steps as you need in order to prove these things. Okay, so that's what typically happens when you're doing proofs. They will start to give you fewer and fewer hints of how to actually prove these things. Okay, so for example, we're given that angle 1 is congruent to angle 4. Okay, so angle 1 is congruent to angle 4. We also have that angle A is congruent to angle B. Okay, and angle, segment ED. So this entire segment here from E to D is congruent to from segment C to F. Okay, so off the bat, there are a couple of things that I noticed. So for example, angle 1 and angle 4, neither of those are in the triangles that I assume we're trying to prove congruent. Well, actually, maybe let's look at the conclusion first. So in the end, we want to prove that AC is congruent to BD. And how are we going to be able to prove that? We're only going to be able to prove that if we can prove that these two triangles are congruent first. Okay, so that's the goal. We want to prove the triangles are congruent. And once we know that, then we know that AC is going to be congruent to BD by, and some books will call it, different books will call it different things. So some books might call it CPCTC, right? So CPCTC, which stands for corresponding parts of congruent triangles are congruent. Okay, so C, P, C, T, C. So some books might call it CPCTC. Personally, I always just write something like congruent triangles forms or implies two congruent segments, if that's what we're trying to prove, that we have segments that are congruent. Or if you're trying to prove angles are congruent, then you would say two congruent angles. Okay, but it's basically the same idea. Once you prove that the triangles are congruent, then you know that all the sides and all the angles are congruent. So whichever conclusion you're actually trying to get from that, you just use whichever theorem that you need. Okay, so we notice that angle 1 and angle 4 are not part of the triangles that we're trying to prove are congruent, but angle 1 and this angle right here, those are supplementary. Similarly, for angle 4 and this angle right here are also supplementary. So that means that if angle 1 and angle 4 are congruent, then their supplements, the two smaller angles that I've marked here, are also going to be congruent. Okay, so that's something that we might want to do, that these two parts are congruent. And then we can also see that the segments that they've given us, the ED and the CF, are congruent. But again, they're too big for the triangles that we're trying to prove. So we're again going to use the subtraction postulate, and we're going to have to subtract the part where they overlap, that CD there, so that we can get that just the portions that we need, the EC and the DF, are going to be congruent. Okay, so that's basically going to be our game plan, and then we're going to actually write out these steps for the proof. Okay, so we have in step 1, we always want to start off with a given. So angle 1 is going to be congruent to angle 4, and that's given. Okay, so now we're going to mark it again as we go. So angle 1 is congruent to angle 4. Okay, and we also want to note that these small angles here are supplementary to those angles. So angle AEC is supplementary to angle 1. Okay, and the reason for that is because a line implies supplement. How did we normally write that? Oh yeah, a straight angle implies two supplementary angles. Okay, some books might also write linear pair instead, or something like that. Linear pair implies two supplementary angles. It really just depends on your book and how they tend to write these kinds of things. Some people might even write linear pair postulate or something like that. Okay, and some people might do this next thing as a separate step, but I'm going to include it in the same step because it has the same reasoning. So angle BFD, so this small portion of the angle right here, is also supplementary to angle 4 for the same reasoning. A straight angle or implies two supplementary angles, or you can think about it as a linear pair. Okay. Then we know that those two small angles are going to be congruent to each other. So angle AEC is congruent to angle BFD because supplements of congruent angles are congruent. Okay, now some books don't actually write that theorem out kind of straight out. So I want to explain this theorem a little bit first. So for example, we know that angle 1 is congruent to angle 4. So let's just write in a couple of random degree measures just so that we can kind of convince ourselves that this is actually true. So for example, let's say that angle 1 is 150 degrees. Because angle 1 is congruent to angle 4, that means that angle 4 will also be 150 degrees. And because these two angles are a linear pair, they're supplementary, which means that the small angle is going to be 30 degrees because they have to add up to 180, which means that this small angle here will also have to be 30 degrees because these two are also supplementary, so they also add up to 180. So basically, whenever you have supplements of congruent angles, they're always going to end up being congruent no matter what degree angle you started off with. So I could have started off with any degree here, but the result will always be the same. Okay, so that's why supplements of congruent angles are congruent. Then, so now we have a portion of the triangles are congruent, right? So this gives us a pair of congruent angles. All right, so there's nothing else that we can really get from that given. So now let's move on to the next given. So in step 4, we have angle A is congruent to angle B. Okay, so we have this angle, maybe I'll use 3 marks here, 1, 2, 3 marks here, is congruent to angle B, and that's just given. And there's not really anything else I can conclude from that, but that does give us another pair of angles that are congruent. So let's just move on to the next given now. So in step 5, we have that ED is congruent to CF. Okay, so we have the entire segment ED is congruent to the entire segment CF. And remember, these parts are too big for the triangles that we're trying to prove are congruent. So we're going to use subtraction postulate, okay? And we're going to subtract the part where they basically overlap, okay? So we're going to, first we need to identify that CD is congruent to CD. Is congruent to CD. And how do we know that? Well, anytime you have something congruent to itself, that's from the reflexive property. So think about it as a reflection in a mirror. Whatever you put into it, you get the exact same thing back out. Okay, so now that those two are congruent, we can subtract that part. So subtracting CD from ED gives you that EC is congruent to DF. Okay, so we have in part step 7, EC is going to be congruent to DF by the subtraction postulate. Subtraction postulate. And again, I like to identify which steps I'm subtracting. So it's step 5 minus step 6. So that means that we're subtracting ED minus CD gives you EC, and CF minus CD gives you DF. And because each of the left sides are congruent to each of the right sides, that means that EC is going to be congruent to DF. Okay, so that gives us a pair of sides that are congruent. Okay, so again, let's look at the order in which we have these. So again, it's not about the order in which you write it down in your proof. It's more about the order in which they are in your picture. So we have an angle, and then we have a side. So we know that the triangles are congruent by, you can either write side angle, angle, or angle, angle, side. That's really your personal preference or the way that your book tends to write it. Okay, and so we have triangle. And again, the order in which you write the letters for congruent triangles matters. Okay, so you have to be consistent. So for the first triangle, it doesn't really matter. Just pick any order for the 3 letters. So for example, I'm going to write A, E, C. Okay, so we have A, then E, then C is congruent to. And so if I look back at the first triangle, A was the one with the 3 marks, then E is the 2 marks, then it goes to the side that's congruent. So I want to do the same thing in the other triangle. So for the 3 marks, then the 2 marks, then the side that's congruent. So that gives us B, F, D. So triangle, B, F, D. Okay, so now that we know that the 2 triangles are congruent, how can we conclude that these 2 sides, AC and BD, are congruent? Okay, and let me just tell you this right now. Whenever you prove that triangles are congruent, the next step after that is almost always, okay, I want to say like 99% of the time, it's almost always the reason for the conclusion is going to be CPCTC, or again, it might be that congruent triangles forms 2 congruent, and again, it depends on what you're trying to conclude, congruent segments or congruent sides. In this case, we're trying to prove that segments are congruent, so we're going to end up with 2 congruent segments. And so we have that AC is congruent to BD by CPCTC, or corresponding parts of congruent triangles are congruent, or because if you've already proven that 2 triangles are congruent, then that tells you that the corresponding segments are congruent.